I have spent a lot of time watching YouTube videos and doing deep research to actually put this video together for you. And let me start by asking, what exactly are AI agents? It's a term that is getting a lot of buzz lately, but it can be quite confusing as well. So let us begin by defining what an agent actually is. Honestly, one of the hardest part of diving into the world of AI agents for me was simply understanding the definition. That is probably because it is such a new and rapidly evolving field that people are still trying to figure out what AI agents are and how they really work. To understand what AI agents are, it is helpful if we understand what they are not. An AI agent is not just an AI system that responds to a single command, what is often called one shot prompting. For instance, if you go to ChatGPT and say, write an essay on topic X from start to finish, it will generate something that sounds relevant and coherent. However, the result is usually quite general and often not exactly what you had in mind. This kind of one time interaction does not involve any planning, feedback, or iterative problem solving. It does not qualify as an AI agent. In contrast, using an agentic workflow can greatly enhance the quality of your results. Instead of jumping straight into the final task, this approach involves breaking the task into smaller, more manageable steps. For example, you might start by outlining your topic, then consider whether you need to do some research online. After that, you would move on to drafting your first version, and then you will evaluate which section need further revision or deeper research. From there, you would revise your draft, continue to refine and improve it until you reach your final version. A non agentic workflow, on the other hand, is much more linear. You go from start to finish in one go. The agentic approach is more cyclical and iterative. You think, you research, you create an output, reflect, refine, and repeat again and again. It's a process of constant improvement, thinking and doing at the same time until you arrive at the best possible result. Alright, let us introduce a little bit more complexity. First, we have non-agentic workflows where AI follows a fixed predefined path, and then we move to agentic workflow where the AI has some decision making capabilities. But beyond that, there's a third level, a fully autonomous AI agent. This is the level where AI can independently determine what needs to be done, which tools to use, and how to adjust its approach through iterative refinement. It loops through tasks, revises, and improves until it reaches a final output on its own. That is the ideal scenario that we are aiming for with AI agents. However, we are not quite there yet. Most of the progress that we have made so far, it is in the middle stage, that is agentic workflows. These systems have elements of autonomy, but they still require human prompting or oversight. Full autonomy might not be too far off, maybe even just a few months away. Now, when it comes to building this agentic system, there are four widely recognized agentic design patterns. The first and simplest of this is reflection. This involves asking the AI to review and evaluate its own output more critically. For instance, you might ask it to write code for a specific task. Once it does, you don't just accept the result, you follow it by prompting the AI to carefully analyze the code for accuracy, style, efficiency, and maybe provide some suggestions for improvement. The AI could review its own code, identify an error, for instance on the line 10, and there's some error, then it can correct it, ultimately refining its output. In this entire scenario, you are just assisting the AI in going through a feedback loop where it reflects and improves its own performance. A simplest evolution of this idea is to remove yourself from the loop entirely. Instead, you guide the AI through this process. You can introduce a second AI that prompts the first one to review and debug its own code. This setup is called as multi-agent framework. Now, let us talk about tool use. By equipping an AI with the ability to use tools, you enable it to break down complex tasks and handle the specific parts more effectively. Take this example. If you're looking to buy a new coffee machine, you might ask an AI what is the best coffee maker according to reviewers. On its own, the AI might give a generic answer, but if it has access to a web search tool, it can take additional steps like searching for the latest review online, comparing different sources, and then summarizing the most relevant insights. This approach results in a much more accurate and useful response than simply relying on a pre existing knowledge. Another widely and powerful capability is the code execution tool. This enables your AI not just to think or respond, but to also create and perform tasks like building a website, solving complex calculations that involve math and logic as well. For instance, you could ask the AI, if I invest $1,000 at a 7% compound interest rate for 12 years, how much I will have. The AI would then use this tool to compute the answer for you. There are also many other tools that you can equip your AI with, such as object detection, web page generation, the ability to access your emails and calendars to automatically schedule meetings, and so on and so forth. The ability to use tools is a powerful agentic design pattern that enables your AI to interact with and impact the world in meaningful goal-driven ways. Let us talk about planning and reasoning. This is when you give an AI a specific task and it figures out the steps needed to complete it. Now, you might wonder why not just use one AI to handle everything from start to finish? And the answer is that AI in this context functions a lot like human. Just as in a complex project, you typically rely on a team of people, each with their own strengths and specialization, instead of one person doing it all. It's more effective to have multiple AIs, each designed for a particular role, working together to get the job done efficiently. Research in AI has shown that using multi-agent workflow where multiple AI agents work together often leads to better outcomes than relying on a single AI to handle everything from start to finish. There are various types of multi-agent design pattern, but at the core of any system is the individual AI agent. Each agent typically consists of four main components: a clearly defined task, what the agent is responsible for; a clear output, what result or answer the agent is expected to deliver; the model powering the agent, such as Anthropic's Cloud model or any other LLM of your choice; the tools and the resources the agent has access to in order to complete its task. The simplest form of a multi-agent system would be two AI agents collaborating on a task. For example, imagine a writer agent responsible for drafting a blog post, an editor agent whose role is to review and provide feedback. Even with just two agents, there are some interesting dynamics at play. An agent can have its own specific task while also contributing a joint task with another agent. This creates potential for overlapping responsibility and interaction. Similarly, when it comes to tools, each agent might have its own dedicated set of tools, but a particular task could also have shared tools associated with it, adding another layer of flexibility and complexity to how these agents operate. You can assign a dedicated tool to a specific task, limiting an agent's access to that tool only when handling the task. Introducing more agents amplifies complexity, creating collaborative dynamics as they coordinate, share information, or even resolve conflicts. While the possibility of configuring agents are nearly endless, I will outline some widely adopted design patterns that have proven effective in streamlining workflows and enhancing outcomes. The first approach involves a linear workflow, often considered the most straightforward method. In this structure, tasks are performed like in a chain, in a manner where each specialized agent completes its designated function before transferring the output to the next agent in the sequence. This is like an assembly line process where responsibility shifts from one specialized unit to another specialized unit. Then comes the hierarchical agent system. A hierarchical AI framework employs a multi-layered structure where a central manager agent coordinates and oversees specialized sub-agents, each assigned different roles. These sub-agents execute their designated task independently and then relay their findings back to the manager, which consolidates the data. For instance, consider a business strategy report. The manager agent assigns the project to sub-agents tailored for specific function. The first sub-agent might analyze real-time market trends using niche data analytics tools. A second could focus on internal customer sentiment by mining feedback from company databases, while a third evaluates operational metrics to assign how a product interacts with broader organizational tool. Once these sub-agents complete their analysis, the manager synthesizes their inputs. The compiled insights might then be forwarded to a dedicated decision-making agent, which refines the data into cohesive, professionally formatted report and proposes actionable recommendations for executives. Now, this layered approach ensures specialized expertise while maintaining centralized oversight. Next up is the hybrid system, which integrates both sequential and hierarchical frameworks. In this model, AI agents operate through a combination of top-down coordination and step-by-step collaboration. A practical illustration of this approach can be seen in the self-driven vehicles. At the highest tier, a centralized AI agent oversees strategic tasks such as route planning and traffic navigation. Beneath this, subordinate agents manage real-time operations like processing sensor data, avoiding collisions, and monitoring road conditions. However, merely compiling this data and relaying it to the primary AI is not enough. A dynamic feedback loop is also needed, as the vehicle's environment, including traffic, road hazard, and internal system, is in constant flux. This requires continuous communication between all the agents to adapt decisions in real time, ensuring safety and efficiency as conditions evolve. The system should incorporate multiple small interconnected feedback cycles among the various agents, paired with ongoing communication to a central coordinator or higher level agent. Another model involves parallel agent architecture, where autonomous agents operate on distinct tasks or workflows simultaneously. This strategy aims to accelerate execution by dividing responsibilities. For instance, in large-scale data analysis, specialized agents might independently process subsets of the data in parallel. Such structures are particularly effective for complex tasks requiring distributed computation. At the highest level of integration, asynchronous multi-agent systems emerge as a framework where individual agents operate autonomously and asynchronously, executing tasks independently and at also varying interval. This decentralized structure has demonstrated superior adaptability in uncertain or dynamic environments compared to rigid sequential or parallel models. Consider an AI-driven cybersecurity threat detection system. Here, Agent 1 continuously scans network traffic in real time. Agent 2 analyzes user behavior for deviations from normal pattern, and Agent 3 performs randomized stress tests on the system. When any agent identifies a potential threat, it triggers alerts and initiates predefined response protocols. Such asynchronous architecture are particularly effective for real-time monitoring, adaptive decision-making, or self-healing systems. Interconnecting this autonomous system form a collaborative network called as float. While these floats enable sophisticated problem solving, their decentralized nature introduces unpredictability. Unlike centralized system, direct oversight of individual agents is limited, though feedback loops can guide behavior. Consequently, scaling this system amplifies both their computational potential and also their susceptibility to chaotic interaction, requiring careful balance between autonomy and coordination. This actually mirrors how human organizations scale. As companies get bigger, complexity and chaos tend to increase, requiring stronger framework like management and hierarchies. Lastly, let us talk about opportunities for AI agents. The most valuable insight I have found comes from a Y Combinator podcast, and it says every existing software as a service company will have a parallel AI agent counterpart, because currently the SaaS leader Adobe, Microsoft, Shopify, Canva, Squarespace, etc. all hint at potential AI-driven equivalent. Literally every major SaaS success story today could inspire a specialized AI agent venture. Tell me if there's a specific AI agent concept that you're excited about. Thanks for joining. I'll catch you next time.